Okay, in this lesson we're going to answer the question, how do I identify the mean absolute deviation and use it to determine variability in data? So if you look at workbook page 347, you're going to see a dot plot that shows 6 values, and the mean of those 6 values is 5. If you were to add up 3 plus 3 plus 5 plus 5 plus 5 plus 9 and divide by your 6, you're going to get an average or a mean of 5. Well, knowing that, the numbers below are going to represent each dot's distance from the mean. So, for example, the 3's here, they are they are 2 spaces away from the mean, which is 5. The numbers that are here are only, they're 0 spaces away from the mean because, well, they are 5. And then this 9 over here, that is 4 spaces away from the mean because 9 is 4 spaces away from 5. So we have 6 distances. We have 2's, we have 0's, and then we have the 4. We have 6 distances from our average or our mean of 5. So now, why is 5 the mean? Well, 5 is the mean because, oops, let me get my pen going. The sum of the values is 30. 30 divided by 6 equals 5. So that's why the mean is 5. What subtraction is used to calculate distance from the mean to each blue dot? So remember, the blue dots were above the 3. So what you probably want to do is 5 minus 3. You're going to take the mean and subtract your 3's, and you're going to get a distance of 2. What subtraction is used to calculate distance from the mean to the green dot? Well, this time, instead of the mean going first, I'm going to probably start with 9 because that's my bigger number, and I'm going to subtract the mean, and you can see that it's 4 spaces away from the mean. So just like what we saw above, this is the subtraction we would do to figure out those distances from the mean. Now, we're going to calculate the mean of the dot plot below, and then we're going to label it. Then, in the space at the right, we're going to write a number for each dot that represents the dot's distance from the mean. So first, let's figure out what the mean is. We have, let's see here, we have 3 plus 4 plus the 2 6's plus 7 plus our 10. And that's going to give me a sum of 36. And then since I have 6 numbers, I'm going to divide by 6, and I'm going to get a mean of 6. So this 6 here, or the 6 is the mean. So now I'm going to write in all the numbers that show the distances from the mean. So let's see, we have this 3 here, and that 3 is 3 spaces from the mean. And then we have this 4 here, and that's 2 spaces from the mean. And then, of course, our 2 6's are 0 spaces from the mean. 7 is 1 space away, and then 10 is 4 spaces away. So I have just figured out the distance all of these numbers are from the mean. Now, this is not in your workbook, but I want you to take a look at this. Here we have Class A and Class B. And these are going to show you the different scores that it looks like 5 students in each class received on maybe a test or a quiz. So it looks like in Class A we have 2 students who got 65, 1 student that got 70, and then we have these 2 students over here who got 100. Then we have Class B. Class B, we have 1 person who got 70, 2 who got 80, 2 who got 85. What I want to do is I want you to take a look at the mean. Each class has a mean of 80. Both classes, Class A and Class B, their average is 80% on this test or quiz. But look at the data. The data is very different. In Class A, you have these two 65s, you have these two 100s, but in Class B, the data seems to be closer together. It's a little more chunked, especially around this 80 and 85%. So this is one of those examples where you may want to use the mean absolute deviation to describe the differences between the mean and some of the other scores. So even though 80 is the average for both Class A and Class B, let's change colors here. Let's go with purple here. So even though the mean is 80 for both classes, these two 65s here, well, guess what? They're 15. I want to pull that down. They're 15 spaces away from our average. And 70. Okay, well then that's 10 spaces away from our average of 80. The hundreds, well they're 20 spaces away from the 80. So that one has a lot more distance between those actual data values and the mean. Whereas if we go down here to Class B, well, we have the 70 here, which is 10 spaces away from our average, and then we have the 80s, which are 0 spaces away from our average, and then we have these two 85s, which are just 5 spaces away from our average. So here you would probably find that the distances between the mean and the actual scores in the class are pretty close together. There's not a lot of variability. They're pretty chunked together. They're not as spread out as Class A is. So let's talk mean absolute deviation. Each display below, and by the way this is page 348, each display below represents the same set of data. The display at the right shows a number in green to indicate each dot's distance from the mean. Use the displays for exercises 5 through 7. So here's what we're going to do. We're going to find the sum of the distances from the mean. And before you start adding and dividing, they actually give you the mean already. The mean of the values there is 4. 1 plus 2 plus 2 plus 5 plus 10 divided by 5 is going to give you your 4. So then over here we have our distance from the mean. That's why 1 here is 3 spaces away from 4, 2 is 2 spaces away from 4, and so on. So we're going to add up all of those distances. So let's see, we've got 3, we've got 2 2s, we've got 1, and then we've got 6. And that gives us a sum of 14. And then we are going to divide by 5 because that's part down here. Divide the sum of the distances from the mean by the number of values. So we're basically finding the mean of the distances. We're going to take our 14 and we're going to divide it by 5 because we have 5 numbers. And that's going to give us 2.8. What does the answer to exercise 6 represent? What did we just find? Well, what we just found was the mean or average distance each data value is from the mean. So the average of the distances, so how far apart all of those different numbers were from the mean, what was the average of those distances? So what we just did was we found the mean absolute deviation. It is the mean or the average distance each data value is from the mean. The mean absolute deviation is a measure of variability or spread of data in a set. Follow the steps below to calculate the mean absolute deviation of the set of data shown at the right. So the first thing we need to do here is we need to actually find the mean. I have to add up all of these numbers, and then I'm going to divide by, let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8, and then I'm going to divide by 8 because I have 8 numbers. So 1 plus 1 plus 3 plus 5 plus 9 plus 9 plus 10 plus 10. That's 48. And then I'm going to divide by 8 because I have 8 numbers. And that's going to give me a mean of 6. So now the next thing we're going to do is we are going to find the distance each value is from the mean. So you can list them out on the lines. You can write them up above if you want. Like, for example, 1 is 5 spaces away, 5 spaces away, 3 spaces away, 1 space away, 3 spaces away for the 9s. The 10s are 4 spaces away. Or if you want to list them down, we have 1 is 5 units away. 3 is, 3 units away. 5 is 1 unit away. 9 is 3 units away. And the 10s are 4 units away. So now we're going to write the sum of the distances. What we need to do is we need to add up all of our distances, the 5 plus the 5 plus the 3 plus the 1 plus the other 3's plus the 2 4's. And that will be 28. And now we're going to calculate the mean absolute deviation by dividing the sum of the distances by the number of values. So we had 8 values, so we have to do 28 divided by 8. And that's going to give us 3.5. So 3.5 is the mean absolute deviation. It is the average of the distances. Which set has data that is more spread out from the mean? Well, if you remember at the top, we had a mean absolute deviation of 2.8. And then at the bottom, we had a mean absolute deviation of 3.5. So I'm going to say the bottom one, the mean absolute deviation is greater for the second set. I'll write that down. And you can abbreviate MAD, MAD. The mean absolute deviation is greater for the second set. Of data. So, come on, wait for me. So the second set is more spread out. Because remember, we said that mean absolute deviation is a measure of variability. It tells us how spread out or how spread apart the data is. All right, I think that was everything. Yep. Okay, let's take a look at our takeaways. So mean absolute deviation, again, a measure of variability that shows the average distance. So it's an average or a mean of the distances that the data values in a set are from the mean. And here are the steps you would need to take to find it. You first have to know what the mean is, and then you figure out the distance each number in your data set is from the mean, and then find the mean of those distances. Add them up and divide by the number of values. And remember that the greater the mean absolute deviation, the more distance the data values are from the mean and the greater the variability in the data.